Now, uh, with the last lesson, we did simple interest, which was the amount of time is the initial amount times 1 plus the rate to the t. Now, most banks don't actually calculate on a simple interest, which is what that old function represented, because people don't leave their money alone for an entire year. Every month they're adding a little bit into their savings, and sometimes they take a little bit out during the month. So the idea is they've come up with something called compound interest, and the idea with compound interest is it compounds the interest. It figures out what it's adding to your account over a interval of time that's less than the big interval that you're talking about. So very common ones would be compounded monthly. So there's 12 months. So you don't get the full rate every month, you get 1/12 of the rate every month. And it doesn't happen just one time throughout the year, it happens every time throughout the year. So um, what they get instead is you get the rate divided by the number of times it gets compounded, and then you multiply that same number by the exponent as well. And that's the big change here. So an example would be if I had $1,000 in a bank account, and I'm getting compounded monthly, it's going to be the rate divided by 12, and there's 12 months in a year. So I would multiply that by the number of years as well. So, I mean, I'm still missing the rate and the number of years that it's in there, but the idea is it breaks it in smaller chunks, but it gives you the interest more times. Um, and that's more realistic in what banks do. Let's go ahead and calculate compound interest for something. An investment account pays 4.2% annual interest compounded monthly. If 2,500 is the investment in the account, what will be the balance after 15 years? So the amount will be the initial amount, 2,500, times 1 plus the rate, 0.042, divided by 12. So you can see the rate is going to be smaller because it's giving you the rate 12 times. 12 times the number of years, 15. So I have 2,500. And what I like to do is I like to take my base value there, the 1 plus the rate over the number of compounds, and I like to figure out that by itself. So 0.042 divided by 12, and I don't even look at that decimal. I immediately just add 1 to it. 1.0035. 12 times 15 is 180. And that's what I'm going to plug in my calculator now. So 2,500 parentheses 1.0035 close parentheses caret for the exponent 180, and I get an amount of $4,688.87. The account will have $4,688.87 after 15 years. So, because we're talking about money, obviously I rounded it to the nearest cent. My bank account isn't going to give me tenths of a cent, even though that's what the gas station charges me. Um, so that's the idea there. Is you just have to figure out the new rate based on it being compounded every month, and then multiplying the number of months each year by the number of years. Now, the compounded monthly is a pretty easy one. They might say other things like compounded quarterly, which means it happens 4 times a year. So there, my n would equal 4 if it's compounded quarterly. So it would be 1 plus the rate over 4 times 4 times the number times a month, and it could say it's Oh, that's kind of hidden by my video there. Let me move that down a little bit. Um, so you just have to read what it says with the compounded and figure out what the end value is. Sometimes it's 4, sometimes it's 3, sometimes it's 12, sometimes it's every 6 months because it's semi-annually, so that'd be twice a year. So it'd be every 6 months it does that. Um, so it would happen twice a year, so n would be 2 in that case. So you just have to figure out what the ratio is. Like if it's semi-annually, that's every 6 months of the 12 months in a year. So that would be 1/2, or n equals 2, because it would only be compounded twice a year. So you just have to do a little bit of figuring out of how often it's compounded.